Many people don't know, when the plane is about to land, the wheels are actually completely stationary and not rotating, but the speed can reach 150 knots at the moment of landing. The most dangerous operation is when the pilot prematurely slams on the brakes. If the stationary wheels hit the runway at high speed, this huge instantaneous friction force will directly blow out the tires on the spot. The consequences are unimaginable. For a large passenger aircraft to land smoothly and decelerate quickly, it relies on the coordinated effort of 4 braking systems. When the aircraft is cruising at high altitude, the landing gear is fully retracted into the fuselage and the wings, minimizing drag and saving fuel. As it approaches the runway for landing, the landing gear bay doors automatically open and are slowly lowered by powerful hydraulic actuators. The entire structure is very stable. At the moment of landing, the entire weight of the aircraft is pressed onto the landing gear. To resist lateral impact forces, reinforced side struts are fitted to both sides of the fuselage, paired with special locking brackets to securely lock them, preventing the landing gear from shifting or wobbling. The front landing gear structure works similarly, except it has a gear and rack steering mechanism, responsible for the aircraft's agile turning and taxiing on the runway. The aircraft's wheels first touch the ground, instantly accelerating from 0 to hundreds of kilometers per hour, while also bearing the weight of the entire aircraft, which is several tons. The landing gear is not just for simple load bearing. Its core function is shock absorption and damping. This is achieved through professional oleo-pneumatic shock struts. The upper cylinder is connected to the fuselage, and the lower piston is connected to the wheel. The cylinder is filled with high-pressure nitrogen, and the piston has a metering pin with a throttling oil hole. When a strong impact occurs during landing, the piston is pushed upwards, and the hydraulic oil inside passes through the small hole to compress the nitrogen, releasing most of the impact force through gas deformation. As the piston moves upward, the metering pin gradually reduces the diameter of the oil outlet, precisely controlling the damping force. After the impact, the nitrogen rebounds, allowing the landing gear to quickly reset, with additional damping devices to resolve high-frequency vibrations, easily resolving high-frequency vibrations. After the aircraft lands smoothly, the entire deceleration process must be initiated immediately. The first to take effect is natural air resistance, but the deceleration effect is negligible. Next was feathers above the wings flip upwards, rapidly reducing the wing's lift, pressing the entire aircraft firmly onto the runway, allowing the main wheel brakes to be fully applied. The center of gravity of civil passenger aircraft is generally biased towards the rear, so most of the weight is on the main landing gear. Therefore, only the main wheels are equipped with braking devices. The front wheels have no braking function throughout the process. Large aircraft have multiple wheels on a set of landing gear, which use the same type of disc brakes as cars, but at a higher level for aircraft, all using high-temperature resistant carbon ceramic freight discs. The rotation of the wheel drives the carbon disc rotor to rotate together. The stator discs on the fixed shaft remain stationary. When the brakes are applied, hydraulic pistons press the discs together, achieving deceleration through frictional resistance. Braking an aircraft can generate temperatures of thousands of degrees Celsius. Ordinary metal discs cannot withstand this. Only carbon ceramic freight discs can handle such extreme conditions. The most common fatal hazard during landing braking is tire slippage. Simply put, a wheel should advance 1 meter per rotation under normal circumstances. But if slippage occurs, the actual distance traveled will be reduced. The higher the slip rate, the more dangerous the braking. Especially on wet runways, slightly heavy braking can usually lead to skidding or veering off course. In severe cases, it can lead to running off the runway. To solve this problem, the aircraft is equipped with a top-tier anti-skid braking system. Each wheel hub is fitted with a high-precision speed sensor. Utilizing electromagnetic induction from the wheel hub's gear ring, it captures the rotational speed of every wheel in real time. All data is consolidated and sent to the central brake control unit. Simultaneously, it compares this with the aircraft's overall ground speed. Once the system detects a discrepancy between the aircraft's ground speed and wheel rotational speed, it immediately identifies a skid. The braking force is automatically reduced. Once the wheel speed synchronizes again, braking force is reapplied. Furthermore, each wheel is controlled independently. If the speed difference of a single wheel exceeds the threshold, the anti-moth braking system directly releases the wheel's brake. It resumes normal operation once the speed is consistent. There is also an extremely hazardous maneuver, locking the brakes prematurely before landing. With the wheels stationary before touchdown, the friction at the moment of high-speed contact is maximized. This can lead to tire bursts at best or damage to the landing gear at worst. Therefore, aircraft are specifically designed with a landing protection mechanism. The aircraft's rear wheels touch down first. The system preemptively compares airspeed and wheel speed. If the speed difference between the two exceeds 50 knots, all brake locks are automatically released. The wheels naturally accelerate upon touching the ground. Once the rotational speed matches the flight speed, normal braking function is gradually restored. The entire aircraft braking logic is extremely sophisticated. Each wheel speed is measured and braked individually, continuously matching speed differences throughout. For absolute safety, passenger aircraft are equipped with 3 independent hydraulic brake fluid circuits. The normal